Oh, there is another chair, same chair like.
Hello. Hello, hi, good evening, everyone, and welcome to today's tutorial session on urban services planning. Am I audible and is my screen visible? Can some of you confirm? Okay, yes, thanks. Thanks for the confirmation. So I think it's just three of us right now, but it's okay. One of us, one. Okay, so maybe we can wait for another 2 to 3 minutes and then start. I think maybe in another 2 3 minutes others should join. Yeah, thank you. Yeah. So I guess a few people have joined right now. So once again, good evening and welcome to today's tutorial session on urban services planning. So today we will be discussing module 4, which mainly discusses about waste generation, storage and minimization. So through all the lectures, all the video lectures, we have observed what are the different sources of waste and what are its compositions, how do we segregate them, how is the waste usually collected, what are the key factors that govern waste generation, and what are the methods by which this can be minimized, starting from individual measures to what are the measures taken by different companies to what are the certain norms or initiatives taken by urban local bodies or government bodies in order to do this. So we discussed all these in a lot of detail. We also looked into certain calculations to see how much waste is generated given the waste generation rate and given the population of a given region. What is the moisture content in a waste in order to plan whether it can be recycled and reused. Or we also looked into what are the compositions of waste. Is it organic? Is organic matter more, or is it non-organic waste that's generated more in a region? We also saw the composition of different countries, how it's varying. So a lot of things have been discussed in the module week 4. So we'll be discussing some numericals and also some theory questions related to week 4. So let's get started. So, first question is, on what parameters does municipal solid waste generation of a city depend on? A. Population and demographic characteristics. B. Income groups in the city. C. Nature of city and lifestyle of people. D. All of these. Can someone attempt this question? It's a very simple question. Okay, D, D, D. Everybody says D. Yeah, so I think that's a very simple question, but let's just go. So we have discussed how population and demographic characteristics influence the waste generation, because as population increases, the waste generated will also increase. So that we are aware. Now, income groups in the city. So it's also said that higher the income group, more waste will be generated because their consumption pattern also increases. Whereas if it's low income group, they will not waste a lot of materials. So the waste generated by low income groups would be lesser. And we also saw that the composition of waste generated by different groups will also be different. For instance, if it's a very low income group, the organic waste which is produced might be less, but as the income so we saw a graph like this which said that for organic waste based on income and waste, initially the waste as income increases, the waste slowly increases, and then it reaches a point where it reaches a maximum, and then after that it slowly starts to reduce. So no, this reduction is mainly because as income increases, yeah, somebody joined, yeah, as income increases, uh, over here the consumption pattern is increasing and more organic waste is being generated. But then after that point, people start buying more of packet materials and less use of like people don't cook much in their houses, so there's less use of all these organic materials, and because of which the organic waste reduces. So income groups in the city, based on that, the waste generation changes, and also the type of waste which is being generated also changes. Then nature of city and lifestyle of people. So this also we've discussed based on the lifestyle in which people are living. So that again comes down to like it is again linked to this income of the people based on the lifestyle in which they're living and the nature of city. So based on the socio-economic background, their practices or the usage pattern of different resources will also vary, and based on that, the waste generated will also vary. So the answer to this, as rightly pointed out by two people here. So the answer is all of them. Population, income groups, and nature of the city influences the solid waste generation. So let's proceed on to the next question. Question 2. Which among the following is not a waste minimization method used by urban local bodies? A. Active awareness campaigns and advertising. B. Training program for sanitary workers. C. Identification and registration of scrap dealers and recyclers. D. Identification and quantification of main generators through data collection systems. There's only one correct answer for this. So somebody says C. Yes. Anybody? Any? C. Identification and registration of scrap dealers and recyclers. Okay. Um. Any other answer from anyone, or is it C? Okay, so let's go option by option. So first one, active awareness campaigns and advertising. So if people are more active, if people are more aware of the waste that they're generating, and if they know that there are methods by which this can be minimized, for instance, recyclable, reusable plastic, or returning the plastic cans to the vendors. So by which you can, such minimization methods, or in general, simple household level minimization methods, if people are made more aware of it, yes, that can be a minimization method, and that is taken by urban local bodies. So we discussed that education campaigns and more awareness is one of the duties of urban local bodies in waste minimization. So this is a waste minimization method. So the question here asks which is not, so which means this is not a correct answer. Now B, training program for sanitary workers. So do you think that by training the sanitary workers, waste minimization can be improved? Yes, no? Anybody, any opinion? No, no. Okay. So, yes, sir. Yes, you wanna share some of your views? I think somebody unmuted. Okay. So yeah, so there's a difference of opinion. So yeah, so as I've been saying since the first class, we can keep our camera on, and if you can unmute and speak, that would be the best thing, because then it becomes more interactive rather than just me asking questions. Yes, yes, ma'am. Suranjana, ma'am. Yes, you can share your views. Great. Very good. Very. Yes. Right. Right, right. Absolutely. So very good for sharing that view. So you're absolutely right. So the option B, which says training program for sanitary workers, yes, by training sanitary workers, we can make the method of waste collection more efficient, and the processing of the waste which has already been generated, the segregation, the processing, the recycling, all that can be made more efficient. But that does not reduce minimization. And as very rightly pointed out, the question only says which of the following is not a waste minimization method. Uh, it doesn't say waste reduction in waste generation, or it doesn't talk about reduction or what do you say? Law or yeah. So it doesn't talk about generation in specific. So yes, there is an ambiguity in the question, but that itself is the crux of the question. Like that's why it's a bit tricky, because initially you might feel that yes, just because scrap dealers are there, by registering scrap dealers, how do they contribute towards reduction in waste, or reduction in overall waste? So the idea is that, as very rightly said, scrap dealers are part of the system, and so what happened until recently was that when scrap dealers are not made officially part of the system, they collect the scrap, and then from whatever they, or from the already existing pool of waste which is there, they collect whatever is needed and they just discard whatever is not needed. So this again is generating waste by generation, in the sense it's just lying out in the open without being sent to a proper waste management system. So, which means it's not coming into the waste management system. So, that is again increasing the overall waste, which has not been there. So, yes, there is some ambiguity in the question, but the question as such talks about what is a waste minimization method, which means that registration of scrap dealers and recyclers are important in minimizing waste. So, this is also a task which is taken by urban local bodies, where they bring in all these. So we've discussed about the Kabaddi system, where these scrap dealers are brought into the system so that the waste which is usually generated by these people, their waste generation again is generated by somebody else, but which otherwise should have gone into the natural, into the systematic plant waste management system. Because of this informal scrap dealing or waste collection by these people who have taken this as their livelihood, a new area of waste is being generated. So since it's not specified household level waste generation, or an industry level waste generation, the answer of C, identification, registration of scrap dealers and recyclers, is included as a method to minimize waste. So C is a correct answer for waste minimization method, whereas D is not. Because again, this is training program for sanitary workers. They do not take the waste and throw it anywhere. They can segregate it and make it better. That's their, by giving them a training program, the system becomes more efficient. So yes, so B is the wrong answer, whereas C is the right answer. And D, identification and quantification of main generators through data collection system. This again is a right answer, because when we know who are the main generators, you can implement certain methods by which the waste generated by these main generators can be reduced, by increasing an increased tariff for these people, or by putting in certain rules or regulations on the waste that are generated. So very good robust data collection system by which by which the problems in this, or the main generators, if we can identify them, then we can take action against these problems. So yes, so thank you very much, ma'am, for sharing your views on this. Yes, it's ambiguous, but given the question, this is the answer. So, yeah. So, shall we proceed on to the next question? Yeah. So, question three. So, this is a small calculation. Calculate the residential waste generated by a city in kilograms per day, which has a population of 2.75 lakhs and waste generation rate of 0.21 kilogram per capita per day. So we have the waste generation rate which is given. So if you look, this is a very, very simple calculation because we already have the answer in the units of the question. So even if you have not watched the lectures, this is very simple because you already know that it is 0.21 kilogram per capita per day. And the question is asking what is the waste generated in kilograms per day, which means you need to remove this per capita out. You need to remove the per person rate out and make it for the total population. So we need to know what is the population of that region. Now the population of the region is also given. It's given to be 2.75 lakhs. Yeah, let me just add someone. Yeah, okay. So it's 2.75 lakhs. So the answer would be 2.75 lakhs. So I'm just leaving it as 2.75 itself into 0.21 per capita per day. So what does this work out to? What does this work out to? Can someone quickly do the calculation? 57750. Yeah, very good. So it's 57750. So what will the units be? It'll be kg per day. We've just removed the per capita out. Yeah, correct. So the answer is A, 57,750 kilograms per day. Any doubts in this question? Shall we move forward? Okay, let's proceed on to the next question. This is another calculation. So calculate the maximum total waste in kilograms carried by a refuse collection vehicle of 20 cubic meter capacity in 2 trips. Consider the density of waste as 500 kilogram per cubic meter. So what we have is we have one truck and the volume of the truck is given to be 20 meter cube and the density of the waste which is there in this truck, or the density of its unit density which is given. So it is given as, did someone want to join? One sec. No, okay, all good. Yeah. So the density is given as 500 kilogram per meter cube. And we've been, and there are 2 trips. So which means there are, let's assume there are 2 containers like this, 2 trips, which means twice. So we have been asked to find the total waste in kilograms. So if we look at the density, we have density. So we know that density is equal to mass by volume. And we have been asked to find the mass. So mass is equal to density into volume. So again, if any confusion, we can just look at the units. So we have kilogram per meter cube, which means it's mass by volume. And we've been asked to find the mass. So we need density into volume. And we also know that there are 2 trips, which means it should be counted twice. So let's do that calculation. So total waste will now be, so this is two times. So 2 times into the density, or to get the this one yeah, into density which is 500 into the volume which is 20. Yeah, so how much does that work out to? 20,000 kilogram. Yeah, very good, Greedy. 20,000 kilograms. So 20,000 kilogram would be the answer. Is that an answer? Yeah, C, 20,000 kilogram. Because you've been asked to find the weight in kilograms, we don't need to do any other conversion. Now, this would have been a tricky question if the question had asked waste in kg and if the density was given as grams per cubic meter. So then we'll have to do a conversion. Or if it was given as centimeter cube. So it's always important. Yeah, thanks. So it's always important to look at the units. So since all of them are in the same units, it's a very straightforward calculation. Excuse me. Let's proceed on to the next question. Just give me a second. Yeah, sorry about that. So problem 5, calculate dry air weight of waste sample if the wet weight of the sample is 500 kilogram and have 20% moisture content. So we know what is the weight of wet waste, and we know what is the moisture content. So we have learned that moisture content moisture content is equal to the weight which is there in wet waste minus the weight which is there in dry waste divided by the weight which is there in wet waste into 100, like normal percentage. So you have the based on the difference of the weight which is there in terms of wet waste and dry waste divided by wet waste into 100. So here, so it's we can just substitute over here. So we have 20% moisture content, so 20 into the weight of wet waste is given to be 500 minus, this is what we are interested to find, divided by 500, right? Into, yeah, sorry, percentage into 100. So yeah, what does this work out to? Yeah, what does this work out to? Yeah, somebody says 400. Okay, very good. Yeah. So it eventually becomes, yeah. So when we take this, when we do the calculation, you will get 400 out of here. Right, 400 kgs. Yeah. No kg, 400 kg. Yeah, 400 kg. Correct. Okay, so let's proceed on to the next question. Problem 6. According to Solid Waste Management Rules 2016, recyclable waste bins are denoted by which color? So we've been asked about recyclable waste bins. So black, green, blue, and white. Somebody says green, okay. Uh, B, green. Yes, two people says green, okay. Anybody, any other color? So we are talking about recyclable waste. We're not talking about organic waste. Let me give you a hint. Blue, okay. Someone says blue. Green as in composting. No, we're not talking about composting. That's organic waste. We're talking about recyclable waste. Sorry, blue. Okay, someone says blue, right? That's interesting to know. Then blue. Okay. So, yes, blue is what you might have observed everywhere for recyclable waste. Yes, Grete says white. White is the right answer because as per solid waste management rules of 2016, it should be white, but blue is also used. But the rule specifies it to be white, but in general, in the public spaces, we always see blue. So if the question is asked as to what is the actual, as per this particular rule, what is it supposed to be? The answer is white. And what is black used for? Black. So black is used for anything other than, yeah, hazardous or something which doesn't go into the recyclable and the organic waste, which usually is the hazardous, domestic hazardous. No, domestic hazardous waste are usually put into black. So yeah. So let's go to the next question. What criteria defines the solid waste bulk generators? A, they oh, we didn't go to the next question. One sec. Yeah. What criteria defines the solid waste bulk generators? A, generates more than 25 kgs of municipal solid waste per day. B, generates more than 100 kgs of municipal solid waste per day. C, none of these. And D, generates more than 200 kgs of municipal solid waste per day. So someone says it's just a matter of how much is the measure that's taken. What is the standard upper limit which can be generated? So somebody says it's 100. Uh, okay. So yeah, so that's the correct answer. B, which generates more than 100 kgs of municipal waste per day. That's the correct answer. 25 is too less and 200 is too high. So 100 is the one which is taken as standard. Very good. So let's go to the next question. Match the type of solid waste with the items in column B and choose the correct answer. So we have different solid waste types and some examples of these elements. So first one is construction and demolition waste, B, biomedical and hazardous waste, R, industrial waste and sludge, S, combustible waste. And column B, we have pathological waste, explosive radioactive material, paper, cardboard, wood, boxes, plastic, cloth, metals, tin, cans, dirt, coal, ash, steel, melting, slag, roofing, and sheeting, plastic, rubber. Okay. C. Two people have already answered the question as C. Okay, let's just see. Construction and demolition waste. That would be V, because roofing and sheathing, plastic, rubber, etc. comes under construction and demolition waste. So yeah, so that's correct in C only. So yeah, that's a very easy guess then, given the options, and none of the options have P equal to V. So, but let's look at the other ones also. Q, biomedical and hazardous waste. So yes, that is pathological waste, explosive, radioactive materials, all that comes under. So anything, it's pathological waste. So pathogens, we know they are the disease causing organisms. So yes, so it's there in the wording itself. Then we have industrial waste and sludge. So that is, yeah, you have coal, ash, steel, melting, slag. So again, we are talking about industrial waste and sludge, and then we have slag, melting slag, which is given. So it's sorry, dude, I just marked it here. Yeah, yeah. So that is coal, ash, and melting slag. And then we have combustible waste. Yeah, so that is paper, cardboard, wood, boxes, plastic, and cloth. Yeah, very good. So C is the correct answer for that. Right, we're proceeding on to the next question. Question 9. Match the EPR tools with their description and choose the correct answer. So we have different EPR tools given over here, and then their descriptions. So first one, P is deposit refund system, Q is quotas, and R is product bans and product charges, and S is collection systems. So I'm not reading the description. Let's go by the options. So we have P, deposit refund system. Which does that work? Which of the descriptions best suit deposit and refund system? Product in packing should contain certain amount of recyclable material? No. Materials which don't allow recyclable products can be banned, and extra taxes levied for use of materials which are not. Okay, so is C the answer for this question, or was it for the previous question? Somebody has put C. Okay, let's see. So, okay, let's not go by this one. You can answer this one. Deposit and refund system, which does it match? One, two, three, four. Retail outlets and produce three. Shall says it's three. Retail outlets and producers can be jointly made responsible for return of packing and used products such as batteries. Okay, that is somebody says three. Let's read the fourth option also. Consumers are charged an additional amount initially, which is returned when container is returned. Okay, so it's deposit and refund system, which means it's the uh, which means you initially pay when you are buying something, and then when you return it you get it back. So yeah, somebody says D. I'm assuming that 4 is what was meant. It's P goes to 4. Customers are initially charged an additional amount, and then when they return the bottle or return the item back, you get that money back. So that's deposit and refund system. Then we have quotas. So quotas, which does quotas come under? One, two, three, or four? Anybody, any guesses? Nobody, no guesses? Quotas. Okay, so quotas means that you have certain. Okay, quota will be one. Correct. Very good. Yes. Right, right, absolutely. So which means there's a standard or a certain percentage value or a certain quota of recyclable materials which has to be there in that particular product or packing. So that's what quota stands for, as rightly said. So R is one, and then product bans and product charges. Which will that be? Okay. So yes, yes, ma'am. Number two, yeah, very good. So materials, so which means you're banning certain non-recyclable elements or certain elements which are environmentally harmful. You ban them from the overall production or from the overall packing material which are produced. So that means you're banning them, or you impose certain charges. For instance, if you use single-time use plastics, there are certain, so single-time use plastics are banned right now. But otherwise, if you're using plastics in general, there are certain charges which are imposed. So this is, yeah, so it works out to two, which materials that don't allow recycling products can be banned and extra tax is levied for the use of such materials which are not suitable. And now we have the collection system, which comes to three, which was mentioned before, where the retail outlets and producers are jointly responsible for collecting these packaging material, what is used, or certain batteries or any other elements which can be hazardous or which doesn't do well to the environment can be collected back by the producer itself. So yes, so that works out to P4 Q1 P4. Is it option D? Yeah, option D. So I think someone answered, yeah. So Greety answered that rightly. I'm assuming option D, that's what was meant. Yeah, so it is option D. Right, let's proceed on to the next question. Problem 10. Dash are provided where door-to-door collection is difficult to implement. A. Recycling plant. B. Material recovery facility. C. Transfer stations. And D. Community bins. Very good. Someone's already answered it. It's community bins because when you can't have a door-to-door facility, there are certain community bins which are placed for a certain local region, and people deposit their waste in these community bins. The other things, recycling plant, for instance, is a recycling mechanism, so which comes after door-to-door collection or after the overall collection segregation, it goes to the recycling plant. So that's not an answer over here. Then we have material recovery facility. That again is not an option. That comes in again the segregation process where we segregate materials which can be recovered, and then you have a material recovering facility to recover those materials out of the products which are already there. So that again doesn't suit over here. Then we have transfer stations. So this we have discussed in our previous lecture also, previous week's discussion, previous module also we have discussed about transfer stations where waste is temporarily collected before it can be transferred to a centralized uh, waste management system. So it can be a recyclable system, it can be a waste, it can be a landfill, it can, so before it's given out to different regions, there are multiple transfer stations where the waste is stored temporarily. So that again happens after the door-to-door collection. But here we are talking about an alternative to door-to-door collection system, which is usually done through community bins. Right. Let's go to the next question. Problem 11. Municipal solid waste quantity, composition, and other characteristics are not based on which of the following? A. Degree of industrialization. B. Natural resources, affluence, and climate. C. Skills of sanitary workers. And D. Socio-economic development. C. Yes, C. So this is very, so somebody has already answered C. Yes, C is the right answer because we've already discussed this in our first question that sanitary workers are part of the waste collection system. They they help in expediting the whole process of solid waste management, but the quantity, composition, and other characteristics are not dependent on the on sanitary workers. That depends upon all the other socioeconomic characteristics, environmental characteristics, the income level of people, all the affluence, climate, all other factors, but not on the skills of sanitary workers. So, yeah, very good for answering that. Now, problem 12. Which sampling method is used to determine solid waste composition? A. Grab sampling method. B. Quartering and coning sampling method. C. Core sampling and testing method. D. Toxicity characteristics leaching process. Oh, I'm sorry. The answer also came along with this. I'm so sorry about that. Yeah. So I think, yeah. So the answer was right there. That is core sampling and testing method. So what you might have you can recollect from the lectures which we have seen. So what from a pile of waste, the this entire pile is made into, oh sorry, yeah, it is B. Did I mark? Okay, I marked it C. Sorry, yeah, it is quartering and cone sampling method, correct? Yeah, quartering. So what we do is we take the entire sample and then we divide them into quarters, and then we remove two quarters out. For instance, these two quarters are removed. So then with whatever is, so something, this would be remaining. And then this is again mixed and then made into another pile. and then again divided, and then you keep doing it until you get 1/8 of the overall portion. And this is the small quantity of this is used in order to determine what is the composition, because it said that when we're doing this method, you get a good composition of whatever material was there. You get a good composition of everything, because you're not taking it from this pile. If you were just taking from one corner, there are chances that the overall composition cannot be understood, because the density won't, or the composition won't be uniform everywhere. But when we're doing this, because you're taking, you're mixing, so in that process we are compacting it and we're making it more or less uniform, so you get the actual composition. So yes, it is, yeah, it is. So again, I'm marking it wrong. It's B, quartering and cone sampling method. This is the correct answer. Right. Yeah, someone has raised the hand. Yeah. Yeah. Sorry, I couldn't hear you properly. Yeah. 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 Correct. 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 Yeah. Yeah. Okay, okay. So usually, yeah, it is 100 kilograms. Yeah, you need at least 100 kilograms usually when we are taking. So by doing this whole process, if it's less than 100 kilograms, is that what your doubt is? Do we like match it up to 100 kilograms? Yes, 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 yes. Okay. So, yeah, so you, okay, I think I'll get back to you regarding this on what is the correct value that this needs to be taken, because yeah, so yeah, let me get back to you. I don't yeah, yeah, right. Yeah, so I think let me just have a look at the lecture also once more on what exactly you're referring to, and I'll get back to you next class. Right. So let's proceed on to the next question. Problem 13. What is the unit of calorific value of waste? So we're talking about calorific value. A, kilojoule per kilogram. B, kilogram per kilojoule. C, joules per kilogram. And D, kilogram per joules. A, kilojoule per kilogram. Yeah, so that's the answer. It's kilojoule per kilogram. So what is calorific value again? What are we talking about in terms of calorific value? Somebody says joule per kilogram also. Yes, I wanted that answer. So that's where the confusion comes. So yeah, so calorific value, we are talking about the heat which is generated by burning around 1 kg of waste, whatever is there. So the heat generation from burning. So for 1 kg, so per kg is there. Now the unit, the standard unit of heat is taken as kilojoules over here, because the value that we're getting is always high, so we take it as kilojoules. Joules per kilogram can also be a unit, but the standard for taking the calorific value of waste, the standard unit taken is always kilojoules. It's not joules per kilogram, right? Yeah, so A is the answer for this. Now, problem 14. Match the types of waste characteristics with corresponding determining factors and choose the correct answer. A. Thermal characteristics. B. Chemical characteristics. R. Biochemical characteristics. And S. Toxicity. Determining factors: calorific value, biodegradable factor, pesticides and insecticides, and carbon nitrogen ratio. So, first one, thermal characteristics, calorific value, which we have already discussed right now. Then, chemical characteristics. Chemical characteristics, it's carbon nitrogen ratio. So we take the ratio of carbon and nitrogen, and then we look at what is the chemical composition of the waste. Somebody says option A. Okay, let's go by this. Now, biochemical characteristics, it's taken by the biodegradable factor, and then toxicity is measured by the pesticides and insecticides which are there. So that works out to option A. Yeah, P is 4 and sorry, P is 1 and Q is 4. Yeah, so that works out to option A. So I think someone's already answered that in the chat box. Yeah, it is option A. Right. So let's go to the next question. Problem 15. Which of the following statements are true concerning waste generation? Waste generation is positively correlated with economic development. B. Urbanization rate affects waste generation. C. Waste generation is related to consumption patterns. D. Waste quantity and composition differs with different income group. So let's go option by option. First one, waste generation is positively correlated with economic development. That's a correct statement. We've already discussed that. The more affluent the region is, the more waste is generated. Now, B, urbanization rate affects waste generation. Yes, that's also a correct statement. More number of people, more urbanization, uh, that affects waste generation. And C, waste generation is related to consumption patterns. That's also right. D, waste quantity and composition differs with different income groups. That's also right. So option A is the answer. Excuse me. I think somebody has already answered that in the chat box. Yeah, it's option A. So let's go to the next question. Yeah, so just to give you an idea, this is what we discussed in our lecture also. So from this source, what a waste. So in that, we have seen on how urbanization is influencing the waste generation pattern based on the GDP. We have looked into different countries, how the pattern of waste generation and the urbanization rate and the waste generation rate, that also we discussed. Now, this is again another problem, which a very similar problem which we discussed. So I think you can do that. Calculate the residential waste generated by city in kilogram per day, which has a population of 5 lakhs and waste generation rate of 0.25 kilogram per capita per day. You can just tell me the answer. There are no options for this. Yes, anybody? Chat box. 125, yep. 1,25,000, yep. So we have already done this. So yeah, 1,25,000, very good. So total waste is equal to population into. Thanks for pointing that out. Yeah, so we've already done this similar question. So very good. That is the answer. It is 1,25,000. So we have total waste is equal to population into waste generation, and we have just done the calculation, and it is 1,25,000. Let's go to the next problem. Sum of the value added of all economic activities in a territory, which is a sum of output minus intermediate consumption plus direct taxes minus subsidies on products, represent dash. That is it the production approach towards GDP calculation? Is it the expenditure approach towards GDP calculation, net domestic product, or depreciation? Any guesses? Yeah, so this is the production approach towards GDP calculation. So we discussed production approach, expenditure approach, GDP depreciation, which is a GDP minus depreciation, which is a net domestic, and the net domestic product. So in the production approach, what we do is we add all the economic activities, which so by what we mean by economic activities, which means that the sum of all the output minus intermediate consumption plus all the indirect taxes and subsidies. So this gives us so GDP is calculated in this way. Then we have the expenditure approach where we have so the other one was based on production. Now this is based on expenditure. So we have all the final consumption of expenditure, then of the non-profit institutions, government, gross fixed capital formation, acquisition of valuables, changes in inventories, exports minus imports. So this gives us the expenditure approach. So here the question had asked sum of value added for all economic activities in a territory, which is output minus intermediate consumption plus direct taxes subsidies. So that is the production approach of GDP calculation. And the net domestic product is GDP minus depreciation. That gives us a net domestic product of the country. Right. So let's proceed on to the next question. Problem 18. Which of the following is not a strategy toward extended producer responsibility? A. Collection system to acquire the return of packing and used products. B. Complete ban of specific products in certain areas. C. Reduction of virgin materials of packing and containers. D. Pay as you throw programs. So first one, collection systems to acquire the return of packing and used product. Is that part of extender producer responsibility? EPR. So we've discussed EPR before in one of the questions also. So it just means that the producer has some duties in terms of the packing material or product that they are serving, that it should not contaminate the environment. So a part of the waste manage the producer becomes part of the waste management system and does certain uh, tasks, also has certain responsibilities towards reducing this waste generation. So yes, collection system to acquire return of packing is an extended producer responsibility because this can reduce the waste generated. Now, B, complete ban of specific products in certain regions. Is that a strategy? No. So that's not an extended producer responsibility. They cannot completely ban certain specific products because as a producer, they're trying to sell it off in different regions. So B is yes, yes, ma'am. Correct. Correct. Oh, yeah. So, okay. Yeah, correct. Yeah, it's not part of producer's responsibility. No, it's part of government. Government can ban certain products. We discussed in one of the previous uh, questions also. That is, in the packing material, also certain ingredients can be completely banned because they are harmful. But that's not an extended producer responsibility. Like if somebody else is taking that decision, they just ban it out. And again, it's not an extended producer. They're not trying to minimize any waste by doing that. So very rightly said. Yeah, it's not a strategy towards EPR. So wrong. Okay, so here the question is asking which of the following is not. So which means uh, yeah, so which means this is not, so which means this is a possible correct answer. This is, which means this is not a correct answer. So here we are talking about correct answer to this particular question. Yes, now C, reduction of virgin materials for packaging and containers. That's something which the producer can decide. Yes, that's something which a producer can decide. They can say that we won't use certain materials, so that's possible, which means it's not the answer for this question. And then comes pay as you throw programs. If you're throwing, if you're generating more waste, you give more, pay as you throw. That again comes as a responsibility of the government or urban local bodies in order to decide on what tariffs needs to be set for these these things. So that's again not part of EPR. So the answer to this is B and C, which is sorry, B and B and D, which is there in option C, correct. B and D. Right. Let's proceed on to the next question. Dash involves, sorry, Dash involves sorting and separating storage of different waste components. A, eco-labeling, B, segregation, and C, disposal. That's a very simple question. Yeah, B, segregation. So you're sorting and separating. Eco-labeling, we know that based on the amount of green products which are there, you get a standard and then you label it as an eco-friendly product. So you have an eco-labeling for that. And then disposal, yeah, disposal is disposal. Now, problem 20. Which of the following statements are true concerning waste segregation? A. Segregation helps in optimizing waste processing and treatment technologies. B. Methane generation in landfill is less due to removal of biodegradable organic materials. C. Easier recovery of materials for reuse and recycling. And D. Waste contamination is lower, resulting in lower volume of landfill. So we are talking about waste segregation. So first one, segregation helps in optimizing waste processing and treatment technologies. Yes, because when we segregate, we can give out based on the segregation, different treatment technologies can be used for different types of waste. Whereas if we don't segregate and we put everything together, then the process is not very efficient. So that's a correct answer. Then we have methane generation in landfill is less due to removal of biodegradable and organic material. All, somebody says all, yes, let's come to that. Yes, so this B is also correct. So we discussed in our last week's module that when it's segregated, all the non-recyclable, non-renewable waste goes into energy production. Then there are certain amount of waste which goes into landfill. So based on the segregation, the amount of waste which goes into the landfill, so especially the organic and biodegradable waste, does not go into the landfill. So because of this, the odor which is generated. So the problem with methane generation is that it'll have a very bad odor. So if you're just opening it out in the landfill, then that odor causes disturbance to people around. So that can be reduced. And then C, easy recovery of materials for reuse and recycling. It's same as this. So yes, that's also there. Waste contamination is lower, resulting in lower volume of landfill. Yes, so this is also there. So both of these are talking about landfill. Yes, so Ranjana ma'am is right. So it is uh, all of them. So which is A, B, C, D. Right. So let's go to the next question. Match the type of domestic hazardous waste with the items in column B and choose the correct answer. So we have e-waste, hazardous waste, and household waste. So e-waste, is it one, two, or three? Three, yeah. So e-waste is printer cartridges, electronic parts like computer, monitors, keyboards, phones, gadgets, any gadget which it comes under e-waste. So yeah, so that's correct. Now hazardous waste. Okay, option hazardous waste, is it thermometers and other mercury containing objects, or chemicals and solvents and other oil lubricants and with all those? Okay, so hazardous waste is two, yeah, rightly said, because it's chemical solvents, other bleaches, household kitchen, everything. Now how, because it's clearly mentioned, it's household medical waste you're talking about. So that is thermometers, other discarded medicines, injections, syringes, etc. So that works out to option A, yeah, yeah, option A, right. Now, yeah, so this was a segregation which we saw in our lecture. So we have wet waste. Yeah, so this we have already discussed about different types of dry waste, cardboard containers, package rags. So I'm not going into this, but yeah, so this is there. Now let's go into the next question. Uh, Again, a very similar question which we did before, so you can do the calculation yourself. Calculate the maximum total waste in kilograms carried by a refuse collection vehicle of 25 meter cubic meter capacity in 3 trips. Consider density of collected waste as 450 kilogram per meter cube. 33750. Yes, very good. That's the correct answer. So the total waste collected, we have discussed its number of trips into the volume of waste into density, because this will give us the mass of the waste, and then based on the number of trips we are multiplying the mass. So yeah, so that's 3 into 25 into 450, so it is 33,750 kilogram. Right. Now, one more question. Calculate the moisture content in waste if the net waste and the, sorry, if the wet weight and air dry weight of waste sample is 500 and 350 kg respectively. This can also be done easily. Thirty, yes, 30 is the correct answer. So we have discussed moisture content is equal to weight of wet waste minus dry waste divided by wet waste into 100. So 500 minus 350 divided by 500. So that works out to 30. Very good. Yes, someone's put the calculation also. Yes, very good. That's the correct answer. Problem 25. Dash refers to the heat generated from combustion of a unit waste of waste. So these are different forms in which the same question can be asked. So they put it in different forms so that uh, the question registers. So this is usually done in data collection where the same question is usually asked in different forms so that there's no bias in responses. So yes, what's the answer to this question? A, moisture content, B, calorific value, C, CN ratio, and B, bulk density. Yes, it's calorific value. We have already discussed this, that the heat generated by burning unit weight of waste is calorific value. Then CN ratio we discussed. In order to find the chemical properties, we take the carbon nitrogen ratio. Moisture content also we have discussed. And now bulk density is the overall, the bulk density of the waste. So that doesn't come anywhere in terms of heat generated. Right. Let's go to the next question. Dash represents the presence of heavy metals, persistent organic pollutants, pesticides, and insecticides in MSW. A, toxicity profile, B, calorific value, C, CN ratio, and D, biochemical characteristics. Presence of heavy metals, persistent organic pollutants, pesticides, and insecticides. Somebody says A, somebody says D. So was the D for the previous question or this question? Biochemical. Somebody says biochemical characteristics. Somebody says toxicity profile. The answer is toxicity profile. Because they're heavy metals, other pollutants, and all that. So it's not just the biochemical elements. Yes, correct. Heavy metals makes it A. Yes, absolutely. So we're not just talking about biochemical properties or chemical components inside, but we are also talking about other metallic waste which are present. So it talks about the toxicity profile. Right, let's go to the next question. ULBs should provide one domestic hazardous storage facility for how many square kilometers? So this is a standard. Any guesses? Is it 10, 15, 20, or 25? 10. Okay, somebody says 10. Somebody says 10. Yes. Anybody else? Any difference of opinion? I think two people have said 10. Fine, but the answer is 20. Uh, it need not be very close. The answer is 20. One domestic hazardous facility for every 20 square meters. That's a standard. Now, question 28. Secondary storage for MSW should allow dash of average daily expected waste. What should be the quantity is what is our secondary storage should allow how much per, like what quantity extra of average daily expected waste. 100%, which means it can cater to 100%, but again we are talking about secondary storage, so that should allow 100% or 150, 200, or 250. Is it that hazardous center is 20 kilometers and regular is 10 square meters? Okay, 100. Okay, regular is 10. Okay, that I might have to check. Hazardous, regular is so regular we have usually door-to-door collection facility, right? If there's community bins, yeah, then you have uh, certain regulations for that. Uh, have we discussed somewhere in the lecture that regular is 10 square meters? I'll have to check that, Shal. And yes, somebody has raised their hand. Uh, is there a okay? Okay, no, yeah, yes, ma'am, yes. The previous question, this one, yeah. Spare capacity. Spare capacity, yeah, yeah. So you're talking about secondary storage, yeah. Yeah, so that would be 200? Correct. Yeah. So secondary storage, it has to be at least double. Yes, 200%. So yeah, so the answer to this one is 200%, because we are talking about the additional. It's not the main storage facility. It's the, as rightly said, spare storage facility. Yeah. So it is 200. And about Shal question, uh, I am not aware whether there's a standard which says that regular has to be kept in every 10 square meters, but there is a standard which says that hazardous, because there is no need of keeping hazardous very close, because the hazardous domestic hazardous waste, the quantity of domestic hazardous waste will always be very minimal, so you need not have like in every household you need not, again, when the collect if it's a collection system, you need not collect it every day, because every day the quantity generated would be less. So if it is a central system where you have public bins, in that case you can place it at every 20 square kilometers. You need not have it very frequently. About how what is the distance in which community bins are to be placed, that I can check, and it's there in the lecture. Now I'm not being able to recollect. Uh, some standard was there in the lecture, but apart from that, this 10 I don't remember. I'm not sure. You can go through the lecture once more in that, and then in case you're not able to find it over there, you can put it in the discussion forum. I'll come and answer it over there. But I'm sure it should be sorted if you just revisit the lecture. Right. So I think that's it. Oh no, so there's a small problem also. The last question. Okay, that's 29. Yeah. Uh, okay, this is a very it's a problem which we did in the previous or the class before that. Week two, we had discussed a very similar problem on a population projection using incremental increase method. Now in this week's lecture also, we discussed certain case studies where incremental increase method was used in order to predict population and the waste which would be generated by this population. So we're doing a very similar problem again over here. So the question is, the population of a city is given, and we have to predict what is the population that would be in 2031 using incremental increase method. So the formula is also given, because in this week's lecture we did not learn the formula, we learned it before. That's why the question itself, we've given the formula. But in your exam, maybe the formula might not be given because it's already there in the overall course. So yeah, so in compared to arithmetic progression and geometric progression, incremental increase method also looks into what is the difference in the rate of change which is there. For instance, if this is A, B, and C, from A to B, if it is 100 and B to C, it is 150, which means the change increase has been, so there's been like 100. Let's talk about people. We are talking about people. So 100 people have increased from A to B. Now B to C, it's 150 people have increased from B to C, but which means that from the rate of change in A to the rate of change in B, around 50 has changed. So which means usually in arithmetic increase, we take the mean of this and then we take the arithmetic mean. But here we are again considering this change also, and then we are taking the incremental increase mean, which is k. So in addition to m, we are also introducing an rate of change for each decade and the average rate of change for all the decades. So you have multiple, if you have D, this value, whatever you're taking, we average this both out and then take K. So let's do this question. So we can just do, because this is only for 3 years, which is already given, we can easily do. So what's the difference? What will be the change in these 2 years? Just write it here. Okay, I'll just go here because I've done the calculation out over here. I mean, we've done a very similar question. So if there's any doubt, you can stop me. So because of that, I'm made a table already. So for these 2 years, we're subtracting and we're getting the value. And then yeah. So this is the total increase which has been there from 1991. I'm just going back here to 2001. So that value we are getting it over here, and then from two, then the value next value which is given is 2011. So 2011, this is the value that we have. So the change which has happened from 2001 to 2011 we have calculated, and we have taken the total and then we have taken the average increase. Now, what is the incremental increase would be for these 2 years? What is the incremental increase which has happened, which is given over here? So there's only one increase, which because we only have 3 years, so only one incremental increase. So we don't have to average. If there were more than one incremental increase, we'll average out the incremental increase also. So this becomes our K, and this becomes our M. So plugging in the values for 2031, again, now we're taking 1991 as a base year. So which means 2031 minus 1991. How many decades are there? We need to calculate that. Whereas if we were taking 2011 as the base year, then our the time duration will also change based on that. I see a problem in this question. Yeah, no. K is correctly taken. Yeah, it's sorted. It's sorted. Yeah, so because it's 1991 and 2031 is what is asked, our K is the amount of years in decades. So there are four from 1991 to 2031. There are 4 decades. So we have taken our I'm sorry, I said K, it is T. So we have taken T as 4, and K, as discussed before, K is this one, incremental increase. So yeah, then all the values have been plugged in. So M is plugged in over here. K is plugged in over here. Yeah, K is plugged in over here. And we are doing the final calculation. Right, yes. Somebody has a doubt. Yes, you can say, you can ask. Ha, ha. Yeah, right. Correct, correct, correct. Correct. You're absolutely. Yeah. Yeah, it changes. The value changes. Uh, yeah, 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 you're right. Usually it's the last one which is taken because that gives more accurate results because you know what's the growth which has happened. But there are some textbooks which refer to as the first year also. So whatever textbooks that we have been referring to, which in our water supply sanitation courses, or when it comes to this one solid waste management courses. Oh yeah, so you can look into Birdie and Birdie. There's this water supply sanitation book. Uh, what is the name of the book? Name of the I'm forgetting the name of the book. So the ones which both methods are correct only. I can give you the in the discussion forum. I'll put the name of the book. So both are correct, but and we are following this method over here in this course and in our previous courses. The other water supply course also we are following this. But you're right. If we use 11, that 2011, that's also right. So yeah. So when it comes to these questions and all that, I think the best option we'll have to look at the best option to see which method they use. Sorry. Yeah, just give me one sec. Just give me one sec, yeah. Yeah, you can ask me. Yeah. Yes. Yeah. Yes. In the PPT, C is to N ratio is given as 1 is to 30, is it? Okay. Can you tell me which slide this is? And okay. Yeah, so if possible, if you can put this in the discussion forum on the which module, which lecture this is, it would be easier because then it's not just me. There would be other uh, other people who are part of this course. They can also have a look at it because maybe it's a typing mistake in the PPT also. Like that's also there. Yeah, thanks. Right. So I think we're done with all the questions which I had for this week. 28 questions. So if there's any doubt, you can ask right now about anything which was discussed in this lecture. How to find incremental increase? Oh, please explain once more. Sorry, I just saw it right now. Oh, okay. So I went a bit fast in incremental increase because we had discussed it in the last class. So I'll go back there once more. Let me just share my screen. Yeah. So going back to this one. Okay, let me not look into any of those to understand. Yeah. To understand it easily, we'll just put it as the year. So let's say year and then the population. I'm just rewriting the whole thing. So in 1991, it's 602500. 2001, it's okay. 2011, okay. So this is the population. Now, if we take the this one increase which is happening in each population, which is our arithmetic mean AM. So we take to take arithmetic difference. So mean will be when we are averaging that out. So to do that, we first find the difference of this both. Then we'll find the difference of this both. So if you can calculate, since we have time, if you can calculate it with me, then it would be easier. If you can tell me what's the AM over here and AM over here. Okay. Yeah, right. Yeah. So let me just check what's the value for this one. That was 37. I'm just writing this value over here. 3797780. And that's one is 79197679. No, wait. 7919768. Right. So now the incremental increase would be what is the difference between these two values? Because in average arithmetic increase, we will take this and we'll average this out. Our incremental increases from the increase which is happening each year. What is the overall, what is the change in your increase? So if you subtract this both, that will give us the incremental increase. So that's what was worked out as. So that's why it is 37977780. Okay, it's written. Okay, this is total increase. Sorry, yeah. The incremental increase, which is 4121988, is actually 791768 minus 3797778. So if we do that, we'll get this value. Since these values are a bit bulky, I understand the calculation's a bit difficult. So that's the incremental increase. Right. Yeah. Right. Any other doubts? Uh, whatever we discussed today. Then, can you read the question? I do not know which is question. Okay. 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 Question is confusing. It's just asked you about what is the composition and what are the parameters you take while evaluating the composition, right? Uh, okay. What is the confusion in the question? Are the options confusing? Is that what? Okay. Okay, I didn't clearly understand what is the confusion. Mm, because yes, the options are a bit tricky, but it can be answered, no? So the thing is, in this, I'm not supposed to be giving out the answer for any of the assignment questions. If there's any doubt on that, like I didn't understand the statement, something, then I can help you out there, but I can't give you the answer out. So if you have like anything specific in that, like what's confusing, if you can say, probably maybe I can just explain that a bit more. Okay. Okay. Yeah, yeah, you can do that. Yeah. Okay, any other doubts, anybody? Right. So if that's the case, we can end today's session. Uh, yeah, so we are finishing a bit early today. I'll be there for another 10-20 minutes. I'll be online. So if you have any doubts, you can join again and then ask or put it in the chat box over here. Or if beyond today's discussion, also if there are any doubts, use the discussion forum so that you can put it there, and then I also know what's a doubt before coming. So if there, while seeing the lectures, also if you have some particular doubt, if you can put in the discussion forum, that would be easy, because sometimes right away I might not have the correct answer. I might have to check also. So yeah, I hope all of you have registered for the exam. I've been told that the date has been extended, but still the number of people registered is a bit less compared to last year. So if you haven't registered, please register, because it's good to have a certificate. Right? So that's it then. Thank you all for joining. See you all next week. Have a good night. Okay, so with that, we're winding up today's session. Thank you.